Hello there. Okay, so hello everybody. This is not a TypeScript tea time, but kind of in the same idea. And in particular, we are kind of doing this as a preparatory session for what we want to do, well, in our TypeScript tea time next time, or maybe in 2 streams, not sure yet. Because one thing that we are missing, let me see. We can bring up the code first of all. So in our TypeScript tea time, we're currently building a kind of Twitch chat Nest.js mongoose-ish application so that we can play turn-based battles against some AI monsters that are not particularly clever because they basically just pick someone randomly at this point and then try to attack them, but Twitch chat can fight with the monsters. And we have an existing Nest.js application for that, and we're currently extending that into a phase where we are actually about to deploy everything. And in preparation of this deployment, I want to check out AWS CDK, the cloud development the cloud development kit, as well as so the general idea. Earlier I had some notes. Here we go. There are my notes. The general idea is, so what do we want to achieve in the end? We want to have a Nest.js running up in the cloud, which we can then ping, and then it just says hello to us. This is in theory fairly simple. We have a few restrictions. The Nest.js app, so the app should just run continuously because that's what we need for our Twitch chat bot listener monster application. As well as we want to Dockerize it, and we want to deploy this the Dockerized application, the container. We want to deploy it to AWS Fargate, and we want to use AWS CDK for this. So these are our restrictions that we have. And given those, we want to now learn essentially together how to do exactly that. So for this, I do have an empty directory here. And the first thing, so having, let me see. I did follow, on the one hand, just the regular introduction to AWS CDK. But other than that, we also have something like, let's see. Give me just one sec to see whether, interestingly, we don't have a Twitter notification for whatever reason. Why not? There should be one Twitter notification. So a Twitter notification, as well as I need to adjust the stream name, in fact. So we're doing a bunch of stuff kind of ad hoc today, keeping it slightly less organized and trying to be, just relaxing and fiddling around with what we want to do. So for that, I'm just currently fixing the stream title. Let's see. So today, what we want to do is we want to have Dockerize or deploy Docker container to Fargate AWS. container, let's say Docker container to AWS Fargate with AWS CDK. So learning, because that's what it is. And here we go. And we say, well, those tags are nice, and it is English. Okay, stream name updated. Cool, cool, cool. Other than that, we also, do I still have it here? Yeah, perfect. Like so. And so. And somehow the link is not correct. Why not? Yeah, doing things ad hoc is always a good idea. Let's see. All I want is to link right here and like there and like that and like that and like that. And then, thank you, Twitter. All right, we got the word out. Perfect, perfect, perfect. Okay, so from now we can actually start with the actual project. Thanks for your patience. So what we want to do first is initializing a CDK app, and we take the language TypeScript, and this is what we are going to do. So this just sets up our basic project, which has then CDK installed and a few, like the first stack that we need. So stacks are the basic units of deployment. And did it work? Yes, it did. Yes, it did indeed. So maybe we take it from here and we just say code dot inside of this directory. We close out this one and have everything here. Perfect, perfect, perfect. Cool. So from here on, so we have our basic AWS CDK application. We see that, so it set up a basic TypeScript project, but it has also some stuff installed. For example, the AWS CDK core, so cloud development kit again. And we see that we have inside of this lib a very, very, very long name. We probably want to rename that into, oh God, Nest.js to Fargate with AWS CDK stack. Still a very long name, but at least slightly better. And let's rename it here as well. Yeah, so by default, if you don't specify anything here in init, where did my init go? Ah, okay, it wasn't in the other directory. Wait, that's fine. In the other VS Code instance. Well, never mind. So what is important here is that we have our basic AWS stack and our basic AWS app. So app is the whole project essentially. And inside of that, we deploy specific stacks. And these stacks are basically CloudFormation, individual CloudFormation stacks. So the unit of deployment, it deploys one stack at a time. First this one, and we could add another stack into this app that we have. which would then be deployed differently and at a different time. But we only need one probably. So having that, I think we also need an application so that we can actually do something with it. And for this, I'm just going to use the Nest.js CLI. Let me just try to find out Chrome here. Come over here, Chrome. So Nest.js CLI. I think I should update it once because my current CLI is like very, very old. My installation. Nest.js CLI npm. This one. How do I install it? Like so. Perfect. Okay. -G. I just want to update it actually. So that should only take a moment, hopefully. And then we can put in, so inside of the AWS CDK project, which handles our infrastructure, we just have kind of a subdirectory for the Nest.js application. It's still TypeScript, everything is fine. And from there, we will build the Docker container and then do the whole stuff that I've written down right here. So this is the first step that we just did. And now we want to have this Nest.js application inside. The good thing is it's basically, it also immediately gives us this endpoint that we want to have so that we can ping it. The thing is, it's of course not deployed anywhere. And we want to deploy it, of course, in the cloud. Because cloud. It's a very good learning, at least. So from here, we do nest generate. Let me see. Nest generate or init. I think it's just init. Yeah, let's go to the documentation, CLI, overview. Install, nest help, generate help, new. Okay. It's nest new, and we call it hello nest. Babams. There it is. Let's take npm for it to install. Apparently it hasn't finished yet. I was a bit too fast. I don't know whether it also does some Git magic. I would like to avoid that because everything should be in one single. So the Nest app and the CDK app should all be in the same Git repository if possible. And it is, of course, possible. Hello Nest. So give me LA, and it has initialized Git. Remove.git. And that should have worked. Did it? I hope it worked. LA. Yeah, looking good. We should see them here as well, though. Ah, there we go. There we go. There we go. Yeah. It looks a bit like Hollow Nest. Like Hollow Nest, the place where Hollow Knight is playing. In any case, let's maybe first of all run our application. So we should be able to open package JSON. Come on. Code package.json. Thank you. And all we need to do is npm run start or yarn start. Works both. So now, first of all, we just want to look at it locally so we see that everything is fine, at least in theory. I mean, if it doesn't work locally, it definitely, or most likely, won't work in the cloud. So apparently it started successfully, but it didn't print anything. They should have added that. That would be very, very helpful. There we go. So console.log, app listening at it does have a host. Let's just say at, and then http :/localhost 3000. There we go. Start again. And this time we can just move here and we see hello world. Okay, perfect. And now that we have this, I think we can also stage everything. Probably. That's fine. We want to look at the app module and we want to look at the app service and we want to say hello TypeScript T time. Or welcome to TypeScript T time. That's good. I like that. Next. So basically that's all that we wanted. We know it works. And from here on, maybe let's actually leave those 2 lines here. At port 3000. Do we have to make it port 80? No, I think that's done via the Docker. I hope. Let's see. So let's close most of this stuff. I definitely want you, because you are the README for today. So maybe let's just save it right into this directory. readme.md, there it is. Okay. Code readme.md. Oh yeah. So what are our learning goals? Our learning goals are learning like this, and we can make this one into double, and then everything is fine. Okay. Now we have this, and we have also this part. We have a basic AWS CDK app, and we have a basic Nest.js app. Let me make these into check marks. So we have this, and there we go. Now the next step is we want to Dockerize it, and as of then we can start with AWS CDK. Looking forward to that. So Dockerization. So we go into HoloNest again, and we open a file called Dockerfile. There we go. And what we want to do at the very end, I think, is run npm start. Do we have to do it with this? I don't quite remember. So let's look at the docs, of course, because that's how we build software. Docker file, Dockerfile reference. We probably also want an example, actually, just that would be much appreciated. So it does run echo hello. So probably we can just say run docker npm start. Save. It's configured as extension MS Azure VS Code Docker is configured as formatter but not available. Select a different formatter. I just want to save it. Whatever. Okay. So we of course have to put some stuff inside of the Docker container. So just running npm start probably won't do it. We have to copy most of the files that we have inside of here. Did I write run correctly? No, it's actually with capitals. Okay. Run. There we go. Okay. So now we need some copies, I imagine. And we probably also want to have an basic image. Docker file example SJS. Maybe there's one. LogRocket helps us to do this. Let's see. They initiated one. Yeah, they also initiate a project here. And then start with node alpine. We just need production, I think. I think we can take all of this. Let's see. Can take most of it, I think. So, we run Linux Alpine, but with Node 12 on top of it. I don't know why they take 12, 13. We just want Node Docker image Node 12. We can also run 14 Alpine. Like so. How do we use it? Docker node full 16 Alpine. So we just write 14 Alpine, I guess, for the latest version. Yep. So node colon 14 minus Alpine. Okay. So that should work. We don't need that part, I think. Oh, formatter annoys me. Sorry about that. We define a node environment variable here, and it should be production. We install only production files. Probably we also just want npm CI actually. We do want package and we want package log. So this is perfect. We also need TypeScript, I think. Ah, okay. They have it kind of multi-staged here because they build on the Docker. Yeah. So they have a separate build step. Let's remove all of these useless empty lines. Okay, so let's understand what's going on. We first build, we need this as production now. We first build an image called development, and all it does is basically build the app. So it installs, and it should only install production. Or is it only development? No, you don't do that, I think. So we just want to install everything, including TypeScript and whatnot. And then we copy the source files, I suppose. We also need some git ignore probably here. A Docker ignore. Because we don't want to have node modules and we don't want to have dist actually. Actually, what we only want is we want to copy source and we want to copy it to /source. So this copies this directory here inside of hello nest. I was about to say hollow nest finally. Into the Docker container source/user source app directory /source. And then it runs npm run build, which will just cause it to run TypeScript compilation, I think. Build nest build. I think it basically runs the TypeScript compilation, if I'm not mistaken. Okay, so we understand that part. As of then, we want to make the production build slightly smaller, because here we install all the... So the output of this gets then used down in the production build again. The output of this is first of all the dist directory. So for this to happen, we of course have to go into tsconfig and see that the output directory is indeed dist. So that's fine. And we actually see the file here. So that's fine. Then, so our basic, actually we can probably just deploy this one, most of it, in theory. But let's go a tiny step further. We probably want to make this the same node version, or things get ugly. So for production, we want to make it actually a bit smaller because it's nicer then. And how do we do that? We say the node environment is production. Okay, that's fine. We essentially we pretty much do the same that we did before, except this time we install only the production node modules. Yeah, I was just making sure that this command is actually correct, and it is. So in our case, we want to install everything again. So the command is correctly, and it only installs production. As you can see here in the production build, so npm ci only production, it adds 106 packages, but the regular build, like the dev build, if you want to, actually adds 870 packages, which is a lot more. And of course, we don't want to. We want to have our production image actually as small as possible, because we first have to upload it, as well as pay for so the upload takes longer, as well as we have to pay for the price for, let's see, the storage that comes with it for the artifact. So far everything is clear. We copy dot to dot. I don't get this step, to be honest. Why should we do that again? Because that would just take everything. I don't see why we need this. So let's ignore it for a moment. Yeah, let's ignore it for a moment. And then from this image up here, we only copy the dist directory, which contains our JavaScript files as well as TypeScript mappings. Those are not that important, but they are nice for debugging. So we have the JavaScript files, and then we just have to run them, which means we can just run node dist/main, and the thing should be all right. I don't see where we need the copy command. So having said that, let's try to actually build this thing. So we can docker build -t, which means tag it. So we call it hellonest dot, and dot is the directory in which we want to execute. We are currently in hellonest, so it needs to point to the Docker file essentially. We are currently in hellonest, so we can just do dot. Let's try that. And then, yeah, it at least has found the correct place. So it's now building this nice little Docker container, or image first of all. So copying stuff, npm installing stuff, running build. Error, could not find TypeScript configuration file. Because we did not copy it. Yes, we also need to copy the TypeScript files here. Not only the source. So we do want tsconfig star, tsconfig star.json, and we want to put them into dot or dot slash. I don't know why they call it dot slash here all of a sudden. Well, I think this should be fine as well. Okay, so these two files get also copied over, as well as the source. And we also have the package JSON, which I'm not sure whether we need for the build step, but that should be fine. And then we can actually try to do this again. I think we need to run it with -- no cache now, if I'm not mistaken. Let's check that. Docker build no cache, because it should do everything again once more. No cache. Yeah, that was the correct command. So this time it's copying it, package JSON, it installing. This time it copies TS and it runs, successfully ran npm run build. Perfect. Next is it goes into the production build. Nice. So sets these environment variables, runs npm CI only production, and I think that's it. And now we can docker run -rm or -rm -d -p. We want to forward, so -p means it's the forwarding the ports. We do want to forward, since the Docker container is running, or inside of the Docker container, the app, Nest.js app is running at 3000. We have to point to the internal port inside of the container. We have to free the port 3000. And just for the sake of simplicity, I open the port on my host machine 3000 to go there. Inside of AWS, we probably don't want to have 3000, but we probably want to have port 80 and 443 maybe, because those are the HTTP and HTTPS ports. Okay, so that one worked, and we can just say it like this. Did that work? That would have been much too simple and straightforward, wouldn't it? It would be kind of boring if it already works. Let me see here. There we go. Perfect. We want to go to localhost. Yay, 3000. Yay. It worked. Do I still have the app running? No. It's actually inside of the container already. Well, that was easy. Nice. Good job. High five. Sweet, 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 sweet. So, resources that we've used so far is Nest.js, just the basic. Or maybe we point to... Yeah, that's fine. We did use Nest.js, of course. So a web development framework inspired by the Angular architecture, using, typically at least, using Express under the hood. And yeah, being just generally a nice thing to use, and it has a lot of plugins and recipes how to do stuff with, for example, if you want to use GraphQL with it, or WebSockets, or microservices, or just as a standalone app. It's all described here. FAQ. Maybe they even have a hot reload. That would be amazing. But I don't know how to do that on the backend. Can you do that? That would be great. Anyway, so yeah, that's one thing. We did use now the. Did I close the Docker image? Docker. Where did we go? We did Node images. Node.js. And yeah, that's the site. So here, from here, we can get the Docker images. Of course, Docker itself also something that is large and takes some time to learn. The basics are you want to run your code not only on your machine, but you also want to have it in a consistent environment. And Docker basically abstracts the environment away and runs on top of that, something like essentially a virtual machine, but more efficient. Yeah, so that worked. That's pretty cool. And now we can actually go. We have this check mark, 5, and we can get into the fun stuff. The stuff where I'm actually not sure how to do it, but let's see. So to learn a bit of AWS CDK, Cloud Development Kit, I've used this. Where's the workshop? Here we go. This nice little workshop, as well as the workshop looks like this. It tells you how to install the CLI and how to set up an initial AWS account, most of which I had already and I do currently also have. And then if you want to do TypeScript, you do TypeScript. So maybe to start one step back, what is AWS CDK? So AWS, first of all, allows you to to build a lot of infrastructure with the help of Amazon Web Services. That's what AWS stands for. And however, it's fairly complex. In particular, there are like, I don't know how many different services, and each define their own ideas and stuff. And they somehow have to play together. So the question arises, how do you manage that? And how to manage it? There are multiple options that you have. You could, for example, use a tool like Terraform, which you then write some code, and it gives you the infrastructure resources on AWS or some other thing as well. You could, for example, also with Terraform, you could also handle Dockerization and stuff. But there are more tools. On the other hand, you could just do it manually inside of the AWS console. Let me log in again here. There we go. Which looks like this. And you could just probably, so what we want to do is we want to go to Fargate, Elastic Container Service. Is just a part of that. Features, EC2. Interesting. Or does it not exist? Oh, that would be bad. If it doesn't exist in Ireland, I mean, you can just switch the region. Let's see. So AWS Fargate. Where does it exist? Tell me. Fargate, which regions? Anyway, so what I wanted to show is this. So you could just do it manually by going through this heavy list and picking out what you want and uploading files and uploading Docker containers and whatnot. But it's very, very hard and bothersome, and you can't really replicate it quickly. Another way is CloudFormation, CFN, where you basically define a JSON file, similar to what you do in Terraform, but more restricted to AWS. And then it just provisions everything for you. So it gives you, for example, a Lambda function with some assets, and which runs some specific function. And it gives you a DynamoDB with some specific tables on it. And it gives the Lambda function access right to the DynamoDB table and so on. And on top of that, you can use the Cloud Development Kit. Development Kit, is it here? No, it isn't. Cloud CDK. Sorry, CDK. Here we go. There we go. And it's basically a step on top of CloudFormation. So in CloudFormation, you would basically just write JSON, and then it does stuff for you. With AWS CDK, you have the power of all of CloudFormation plus a bit more, and you are actually using a general programming language, which is TypeScript, JavaScript, Python, Java, C#, .NET, and actually also coming Go to simplify the process of writing CloudFormation JSON. For example, if you want to have just a VPC, you write it like this, and webams, everything happens, the magic. Or if you want to have an elastic, this is actually our application, nice. If you want to have a elastic container service cluster inside of this VPC, you basically do this, and everything is fine. Or if you want to have an application which has a load balancer in front of it, deployed with Fargate, then you do this on top of the other ones, because this one is actually used inside of here. And the VPC is used here. I think the VPC is not needed, by the way. And this way so it compiles, and it compiles into CloudFormation code, plus some static assets, like when you, for example, have a container image, it somehow has to save it anywhere, and it can, of course, not save the container image inside of JSON, CloudFormation JSON. So it puts it somewhere else, typically a NS3 bucket, just storage on the cloud in AWS. Yeah, so that's what we are trying to do, and it's pretty much exactly this code. I'm inclined to actually copy it. In AWS CDK, did I already put this here? No, I didn't. Okay, here we go. In AWS CDK, you typically, so it builds on top of CloudFormation. That's why it's using a lot of the same notation. So we have the big cloud CDK app, which just encompasses the whole project. And inside of there, the pieces of deployment are these stacks. And what you typically write is a stack. So what we are going to do, we already have that part somewhere in here. And inside of lib, there we go. We have this stack. So it extends the cdk.stack class. They call it constructs. Basically, components that you can deploy. Components or collections of components again. So you can piece stuff together, and you can build your own components, or use components from another person who already put, for example, all the, in this case, it deploys a complete load balancer, and it deploys a container to Fargate. So a lot of stuff, and it also handles all the security stuff for us. This one command. So that's pretty nice, and we will use this composition to exactly basically copy this text. It can be so easy. Let's see whether it actually works. I'm curious. I'm very curious. So what we want to do is, okay, let's actually put it inside of a VPC, just for the sake of having it. And what we need to do is we have to install it. We have to step out of hello nest, and we need to go inside our root directory, which we are now. And what we want to do here is we want to npm install at AWS CDK / it is just AWS EC2. That's a question that I have. I have questions. Ooh, nice. So they probably tell us what we need to do. Okay, let's start here. So what do? They create a new directory, and they create also a CDK project. That's what we did. Now what they do is calling this CDK synth. Synth means it's taking your TypeScript code, or Python or Java for that matter, and it's compiling it into CloudFormation code. So what we will see is that if I run this command here, let's remove this once more, CDK synth, then it creates a CDK out file, and inside of here we see the Fargate stack.template.json. This is the CloudFormation file. So that's good. And it created this automatically. In fact, we can actually delete this because you can always recreate it. So we have this. And now what we want, oh, I scrolled too far. Here. We want to install EC2. So EC2 AWS is Elastic Qt Computing. So these are basically, Elastic Compute Cloud, yeah, thank you. These are essentially virtual machines inside of the cloud with slightly more complex. And they are not really virtual machines, if I understand this correctly. Or maybe they are. I don't know. Yeah, rent virtual computers. So we want that one because that's where our container will run on. We do want... No, actually we're using Fargate, and I think Fargate is just inside of this workspace. Or inside of this one. I'm not 100% sure. Let's see. ECS is Elastic Container Service. So that's where we basically Docker, where it's running the Docker containers. And we have ECS patterns, which is just ready-made stuff for using ECS. So in our case, we will get a load balancer and the Fargate service out of it. So let's do that. Put it in. And then that should be fine. So create a Fargate service. There are two different ways to run a container with Amazon ECS. Okay? So they are called container tasks, not just containers. So one is Fargate and one is EC2. So Fargate is basically, they abstract away, it's basically the Lambda for Docker. Or if you know Heroku, Heroku is very, very similar in that sense. EC2, however, is when you want to have the control, and you can dive into the servers and look into the virtual machine and look into it and see what happens and whatnot. So you have a lot more control, and you can also do other stuff, of course, with it. So you're not limited to just having this one container running in it. With Fargate, it abstracts this EC2 part away. So we don't have to care about it. We can just, as long as we have a Docker container, it just runs it. And that's pretty nice, because I don't want to need to care about the infrastructure too much, if I'm perfectly frank, because that's not driving my business, right? What drives my business is the application logic. Let me just rehydrate here for a second. Very important when talking for a long time. So we will do Fargate, so without EC2, which makes me wonder why we actually imported it, but nevertheless, let's see how it goes. So because they create the virtual private cloud from there, we can also just skip the VPC if I'm not mistaken. So let's, I think this is optional. So ECS, of course, we need to import. So imp, we want to import from AWS ECS, and we call it star as ECS. Thank you. And I think this one is optional. So by default, it creates a new VPC with 2 AZs. Oh, okay. That's why we want the VPC, because we want to avoid any costs. So we do max availability zones is just 1. I'm not 100% sure how the pricing works. So there's a free tier, a very generous free tier on AWS, and actually on most cloud providers. What I don't exactly know is, so you can have VPCs in multiple spanning multiple availability zones where it should be accessible, and what I don't know is what the maximum is on the free tier. It might be 1, it might be 2. I'm not perfectly sure at this point, but that's fine. So let's also take that one, and we want to have it only in 1. So be aware that environment agnostic sets will be created with access to only 2 AZs. So to use more than 2 AZs, be sure to specify the account and region on your stack. Okay, whatever. So having the virtual private cloud is just a additional measure. What we really care about is this ECS cluster in which we want to deploy our ECS instances, our containers. And the way we do deploy them is with the help of Fargate. And that's where we do this. And I need to close some brackets here. Close. And import this /ECS patterns. Yeah, perfect. So this is what we actually want. This is our application. So inside of here, we need some fun stuff. What do we need? So let's see. We don't need to fiddle around with the CPU. I think it's just the smallest anyway. So that's fine. Let's look at the memory. 512 is also the minimal. No, 265 is the minimal, but I suppose we are. Yeah, let's do 265. Then, what's much more important? So usually it should say cluster. I'm surprised. Oh, it creates it by default. It creates a new cluster if both cluster and VPC are omitted. A new VPC will be created for you. Man, so basically we don't even need this if we want to really go hardcore. It might go on my paycheck though. So let's just do this. And specify the cluster with 1 availability zone. I need to also take another look at what availability zones are. Not sure yet how they exactly work. So we do want the public load balancer. So it says, so it determines whether the load balancer will be internet facing. So why do we need a load balancer? Because the inside of the ECS cluster, so they try to keep it running, but they are still Docker containers. So if they go down, they will redeploy them, but they don't, with Fargate at least, they don't guarantee that they get redeployed on the same machine. So the IP address may change. And the load balancer automatically gets updated with the newest. So if the container gets run up and running again, it might have a new address or URI. So the load balancer has to somehow, the load balancer essentially for the internet user, for the public user, abstracts away that behind the scenes, the container IP address changes all the time, probably, maybe. Anything else? We want desired count to be 1. That's enough. we don't need 20 containers to listen to say us hello. That should be fine. What we definitely need is this here. How to build the task image options. So what does it say? Yeah, how does it build the Docker container that it should deploy? And what we want is we do need an image. So the image used to start a container. And we do want to use which image? So we want ecs.docker, no, not Docker, container image. Dot from, I think just from asset. So reference an image that's constructed directly from sources on disk. If you already have a Docker image asset instance, you can use that from Docker image asset. And oh yeah, I think this is what we want from asset. So it receives a directory, which is the directory in which we find the Docker file. So what we want is to write /hello nest, because that's where our Docker file lives. Do we need to run set the context? Apparently we don't. Hopefully that works. So let's give it a nice name. Hello nest. So that's the container name now. Any labels, enable logging flag to indicate whether logging is enabled. Yes, we want logging, so it's defaults to true. We don't have to care about it. The container port is important because it's pun not intended. Because it's actually not running on the regular port. Oh, does that make a difference? Wait. The port number on the container that is bound to the user-specific and automatically assigned host port. Yes, then we want port to expose port 3000. Yeah. So it's basically the equivalent of what we did here, where we had I think this one is the internal port pointing to our local host machine. So the Docker container port 3000 points to the local host machine 3000, and this one could change. This one or maybe the other, I'm not sure which one is which. So this one could also go to 80. And then it's available on localhost 80. But this first one is very important because that's how it's defined inside of the, I think it's main.ts. Yeah, this one. So that one's important. Yeah, and I think from here on, we're good. We save and we do CDK synthesize. So just to see the output, we could also just run deploy and see what happens, but probably not the best idea. And in this case, oh, it does a lot of stuff here. It does a lot of stuff here. Can we look at the, let's open the JSON because it's easier to read, I think. So we created a VPC here, which has this name apparently. No, it has this. No, that's only the tag. Wait. Metadata, resource. I think this is the name. this name is only inside of the, either this one or that one. It's only inside of the stack. Then we create a subnet and we expose this subnet. We have some routing tables, and all of that was basically not visible to us. More subnetting. Well, I'm very happy that that we didn't have to write this, right? I mean, there are a lot of tags inside of here, but nevertheless, that's quite something. If that's all of that is needed, wow, wow to the person who writes this by hand. It creates an internet gateway from AWS here, from EC2 here. Sorry. So, yeah. So somehow it points to, it allows access to EC2, the VPC gateway attachment, which probably gets attached to the load balancer so that the load balancer can point into the VPC and into the correct EC2 instance. The cluster, which contains the stuff. An elastic load balancer. Some security groups which are needed. So we allow access from port 80. Here, this is important. So we have essentially, they essentially run this command. From internal port 3000, go to external port 80. It might also be vice versa. I'm not 100% sure again. So that's very important. That's why we need this container port. Wait, that's for the load balancer. Is it? Wait, what? Security group for EC2. No, that's for the container, I think. They have another one from port to port. Interesting. Yeah, I'm curious whether that works. Some assume role policy to create these tasks. No, ECS tasks is allowed to access what? They are allowed to access what? Should there be a role or something attached to this? Or can this service can just use any role now? So STS is secure token service, which just handles anything related to tokens that are not either anything that's related to tokens or just time-based tokens. I would have expected some resource inside of here that we are allowed to access, but maybe not. What else do we have? A task definition. I think in the meantime we can, no, let's continue here. Here's the log stuff that we have. And it's called Hello Nest. That's nice. Is this our actual instance? Yeah, this is the actual task definition, the actual container. Here's the image. Apparently, so it's using some asset here. Configure some logs, some port mappings, the CPU that we required, the memory that we required. Not sure what a family is. What else do we have inside of here? Task definition execution row, so that something can call it. And this something is ECS tasks.amazon, Amazon AWS.com. Maybe this is is this Fargate? I'm not sure. More execution roads. So by the way, I will destroy everything of this after the session. So even if something relevant is inside of here, nothing will persist after the session. Next, what else do we have here? We have a ECS service, which is it references the cluster, or it is the cluster. It also has some load balancers, a network configuration, and it depends on stuff so that it has the correct order in which to deploy. All of that is handled for us, which is really, really nice. More security groups. Anything relevant inside of here? Outputs. That's already handled, right? The DNS name. So outputs is, or CloudFormation outputs is what comes back essentially. For example, if you deploy an S3 bucket, you probably want to, at the end of running the deployment, you want to know the URL on how to access the S3 bucket. So that's what you use outputs for. And we want to have the URI of the load balancer. And I'm very curious whether that's already exported thanks to this guy, this pattern, or whether we have to output. No, there's nothing about output. We can just go inside, I think. It's right here. And then we can look at it. Do they have any outputs here? They don't. Public. So they have a public, assign public IP address. What do we have? Load balancer, right? There's nothing about load balancing here. Apparently all the load balancing stuff is somewhere else. Here, maybe? Load balanced. Network load balanced, blah blah. Application, multiple target groups. Yeah, but one nice thing is we can actually step inside and look at all of this fun stuff if we want to know more. For now, I think we're fine. What else do we have in the... Oh no, did I close it? No! I think I stepped back. Come on, get me back to the JSON file. Come on. Some more. No, one more. 1, 2. Yeah, there we go. So if we're lucky, we see it. Otherwise, we have to go somewhere deep diving and try to figure out how to get the URL. A lot of conditions that are not relevant, but related to regions. I think this is the point in time where we run deployment. So we did run CDK synth, and now it is time. So just to verify, where is my AWS here? Twitch Fargate with regions. You can close that one. I do want to include you here. Didn't I have it open at some point? Let me sign in again. Okay, that was easy. So currently we have essentially nothing on here. For example, inside of this friend CloudFormation, we don't see any stacks. Inside of S3, we don't see any buckets. I hope. Yeah, I deleted these earlier, so that's why they are not found. This will update in time. They are leftovers from the workshop that I've used. Hope they don't bother us too much. So other than that, everything is pretty much empty. One thing that I think I need to run is the bootstrap, which they don't have here. But I think we need it. Maybe it wants us if we don't. Let's see. I'm curious. So let's try it. This would take a while. So either it fails immediately because we don't have the bootstrap done, or a lot of security. So it again, if there are any security relevant changes, it will ask us. If it does not include any security relevant changes, it actually doesn't. So in this case, we want to allow. Oh, this stack uses assets. Nice. So it actually warns us. So the stack failed, error. This stack uses assets. So the toolkit stack must be deployed to the environment. So the toolkit stack is basically where we put the CloudFormation files that are too large, or also assets like the Docker image. And it's taking this, I think this one. Yep, the CDK toolkit bucket, staging bucket, which it creates for us. So this command, basically you run it once for the complete account per region. So if you never switch the regions, everything is fine. You just have to run it once. Otherwise, if you change regions, you have to run it again. I do have in my AWS configuration, I have a default region set up. Be aware of that. So the AWS credentials say they define which credentials to use, and yeah, and in my case it uses this account, which is called TypeScript Deep Time something, or the user is called like that. So Bootstrap was successful. We should see, if I reload here, in soon time, yeah, there we go. We do see this staging bucket, and we actually also see now in CloudFormation, thank you, this first toolkit stack. So the CDK toolkit stack, it was created by CDK Bootstrap and manages resources necessary for managing your cloud applications with AWS CDK. Basically, you never delete it, but I did it anyway, just for having it also in the stream. So from here on, this time we can deploy. And this time it will take a long time because it has to deploy so many things, security groups and services and more stuff. Immediately it starts running our Docker container, which is nice. Most of this is using the cache apparently. And now it's pushing to a repository. Interesting. All of that automatically, because I have never seen this repository before. And that worked. That's nice. So maybe we already see something inside of here, or probably the registry service. So there's also, to the Elastic Cloud Service, ECS, we have the ECR, the Cloud Container Registry. And that's where we see it. Hey, nice. Tag immutability disabled. And this is our application. Apparently it's 45 MB big. That's still pretty large for just npm init essentially. Node nest image. Nevertheless, yeah, it's doing stuff. We also should see the CloudFormation stack by now. There it is, and the creators in progress. So again, as soon as we did run the synths, oh, that's not good. Oh, that's not good. No Fargate configuration exists for given values. Ooh, that's not good. Rollback in progress. Oh, interesting. It automatically rollbacks. Rolls back. Sweet. I didn't know that. They don't mention it, at least not in the logs. But that's probably, if I think about it, that's probably a feature of CloudFormation stacks. Yeah, they call them, these stacks are the units of deployment. So if something inside of the stack fails, it reroutes the complete stack probably. Maybe that's how it works. Maybe we can find out. CFN stacks on error rollback. Oh, it can be stuck. That's not nice. Can we do it from here? Like if I do click here, stack actions, cancel, continue update, rollback, cancel update stack. Rollback in progress still. Yeah, I wonder, so oftentimes the assets are not properly cleaned up. Maybe we'll still see this. On the other hand, it's already deployed, so maybe it doesn't redeploy it. That would be nice. I'm wondering, however, what went wrong. Let's maybe try to grab, no, not this output, but no, it removed the output. Oh, that sucks. Ah, I think this is the output. Very nice. Okay. Shift C. Let's look at the output here for a second. And change this to format, no, language mode log. It's slightly better. At least we see some stuff. Error is red. Invalid request provided. Create task definition. No Fargate configuration exists for given values. Service Amazon ECS. What is that supposed to mean? Did anybody have this? Yeah, nice. So, what happened? So what do I see? Closing this issue. It looks like your task size values aren't valid for Fargate. Your mem limit is too big for the CPU limit. Is that it? So do we have any nice output here? So are there then that it failed and it rollbacked, which is nice. It failed. The stack named failed creation. It may need to be manually deleted from the AWS console. Rollback complete. Meh. That's annoying. So the assets are definitely still there. Oh, I really like this, that this happened, because it's immensely nice to know what happens on errors. And you don't want to have them in production, right? It's nicer to have the errors in a safe environment. How do they call it? I think it's this. The term is small fish learn to be big fish in small ponds. Yeah, so this is a small pond, of course, because no real money is behind this, except for my 3 cents that I have to throw at AWS. And no real customers behind this, so nobody gets angry. I'm very happy that this happens now and not at work, for example. So the stack named blah blah failed creation. It may need to be manually deleted from the AWS console. Rollback complete. Okay. The stack. Okay. Thank you for telling me twice. So in that case, let's just remove the memory. Try again. Because it seemed that the problem was with the memory. I hope so. Does it use the same stack? Yeah, it uses it. Nice. Review in progress. Interesting. Review. I'm curious what happens now. Looks like your task size values aren't valid for Fargate. Mem limit is too big for the CPU. I mean, we had... Huh. I wonder. By the way, we didn't run synthesize, but it automatically runs synthesize again. So inside of here, yeah, we should see 256 for the CPU, but memory, it says 512, which we did not specify. So hopefully that's it. Let's not celebrate them before we actually know that everything works. In the meantime, let's drink some tea because we're the TypeScript tea time. I should come up with a jingle. Shouldn't we have a jingle? I would love to have a jingle. Oh no, it fails again. Availability zones must be specified. Oh, okay. We at least need 2. At least 2 subnets and 2 different availability zones must be specified. Status code 400. Okay. Then we take 2. So that said, we don't need the VPC in that case. And I can just get rid of it because it uses the default. In that case, we can probably get rid completely of this as well. I hope I'm not messing things up because it's rollbacking in the process of a rollback. I like that it goes down. Yeah, like that. So we actually specified too much, which is kind of funny. So if both cluster and VPC are omitted, so we can actually also get rid of the cluster. Seriously? This is all we need. If this is all we need, I am very amazed. I mean, we're not talking about a single Lambda function or something. We're talking about a complete load balancer with a public IP, which automatically points to EC, let's see, to Fargate services, to an ECS cluster, which contains multiple resources. In our case, only one, but still, which contains our container image and runs everything automatically. And also the Docker command is run automatically, and it uploads to the registry and stuff. So seriously? All of that with this little code? Man, Codeless has a new dimension, I think. So it failed to deploy. Yeah, thank you. We already know that. I don't want to call yarn deploy. I do want to call CDK deploy. Attempt 3. Yeah. Yeah. I'm curious how it does the roles. So I don't want to see the users. I do want to see the roles. Let's see. For support, API gateway. I think I created that one. For ECS, the service linked role. List activity none. I think these two are actually from the let's see, but it's 6 days old. Yeah, I think these two are actually, oh no, this is serverless. Okay, never mind. I accidentally actually deployed this one. I should probably just remove it at some point. On the other hand, these are service linked roles, at least these 3. So we don't really have to worry about them too much. I could delete this one, but won't for now. It looks fairly good. Did it, by the way, duplicate our containers? So this is running registry. It has the container registry. There we go. No, it didn't. Nice, sweet. So it's always taking the same image, not even if we change the whole pipeline. Let's say the stack. It's not a real pipeline, but to a degree it is. Public. Oh, we also have public repository. I learned a new thing today. So other than that, let's go to cloud. No, not cloud. CFN. CloudFormation. Create in progress. We also see it here. Yeah, so this takes a while. In the meantime, I can sing a bit and be happy about life. Let's see. Yeah, if this actually works, I'm very amazed. Very amazed. Did I already say very amazed? But I'm very amazed. Like, very amazed. Here we are. So we are currently trying to deploy the AWS container to Fargate, which is Farscape together with Stargate, and together they become Fargate. Come on, you can do it, CDK and CloudFormation. You only need to deploy the route and the net gateway and also the Elastic load balancing v2 load balancer, which is called my Fargate service LB. Yeah, this is Fargate service LB. Going through the ECS default cluster M subnet 1 default role 36, 37. Oh my goodness, I can't wait. Hopefully it shows us the URL. If it doesn't, it would be kind of annoying. Finding the URL. We probably already have the load balancer now. So if we go to Elastic Load Balancer, ELB, load balancers. Ah, it's the EC2 feature. I didn't know. It's here. Is that the? It's called DNS name. Is that the same as just the URI? That would be nice. It worked. This time it worked. It does output stack load balancer DNS name and service URL. So maybe we go to the service URL because it includes HTTPS. So we can click on it. Other than that, it's basically the same. It's just with it works. Dude, it works. It's not HTTPS, unfortunately, but still. That's amazing. That's amazing. Jesus Christ. We did all of that with this little code. Jesus Christ superstar. One very important thing for me now is, so first of all, congratulations, we did sorry, I pressed the wrong button and was confused for a second. We did what we wanted to achieve. T for everybody. Yay! I'm amazed. Like seriously amazed. It would be nice if we can push this to HTTPS as well. Like if you go with serverless, you automatically always get an HTTPS website. But nevertheless, or can we just do HTTPS here? No, it probably can't. HTTPS : /. It probably won't work. Can we add something here? Secrets, environment, enable logging. No, that's, wait, not in the task option here. SLS, SSL. No, security groups, HTTPS, redirect HTTP. Specifies whether the load balancer should redirect traffic on port 80 to port 443 to support HTTPS redirects. Only valid if the protocol of the ALB, application load balancer, is HTTPS. How do we set the application load balancer's protocol? Did it? No, it's still not. We actually use a cookie. The load balancer uses a cookie apparently. Interesting. Load balancer name. We can supply our own instance, which is also interesting. But other than that, it doesn't look like it. Well, certificate. Certificate manager certificate to associate with the load balancer. Setting this option will set the load balancer protocol to HTTPS. The DNS validated certificate will be created for load balancers. Specified domain name. So we just say, what is this? A string? True. An I certificate. Certificate are ARN, env, node, and a stack. Interesting. Okay. Not relevant for us now. But other than that, dude, we did it. We've blasted this, knowing nothing. We actually removed most of the code that we got. So we copied initial code and then we removed from it because most of the defaults are just too good, except for the container port. And voila, we deployed a big fat infrastructure of, I don't know how many. Jesus, it created over 1,000 lines of code from this. And it just works. I'm amazed. So from here on, let's try something new. So what I want to see is whether it persists stuff. So whether the instance stays online. Because we want to have it continuously running, right? And not like a Lambda function being turned down and up and down and up again. The containing Docker container. But it's fast enough so that I think it's actually working as expected, like running all the time. One more interesting thing is how will CDK deploy act if we change the Docker image, or if we change the underlying code of the Docker image. I'm very curious about that one, to be honest. So change some code to have a counter, a hit counter, and return the count. And then we see what happens. So we go into controller, probably app controller, or into app service.getHello. Thank you. So let's put in a private variable here. Private hit count, and it's a number, and it starts at 0. And we do hit count plus plus. Welcome to TypeScript deep time, \n. Endpoint called, that was the wrong button. How many times? Hit count times. We'll stop. So we have changed some code now. If we run CDK deploy, it needs to rebuild the image to a degree at least. It needs to rerun the image as of this point, if I'm not mistaken. Yeah, when it copies the source. Let's see what it does. So 3, 2, 1. Does it actually start? There we go. It starts deploying. It starts publishing immediately. Oh no, it doesn't. Here it didn't use the cache. So it worked. Man, that was fast. The removing intermediate container. Yeah, it's nice of you. Using cache here, didn't use the cache again. Man, this is amazing. It's amazing. Jeez, I can't wait to show this in the TypeScript tea time. It's amazing, and all of this is basically just code except for the initial setup of AWS account, which is like once per year, let's say. Or yeah, let's say once per year. I haven't done it more often so far. And now it's doing the thing again. And it's probably not... It's skipping most of the stuff. Because it only has to change some stuff. Oh, we should have run... Yeah, we should have run the diff before we actually deployed. It would have been interesting to see how it looked. Very, very interested in that. So let's do that again and run it with diff. But other than that, it looks like magic. A serious degree of magic. Come on, can do it. Fargate. Deploy the thing. We should now see inside of the load balancer. No, the load balancers should actually stay intact without any changes. We should see changes in the registry, however. Why is that in Japanese? What the fuck? So it says repository. I have no idea why that's in Japanese. Why is it in Japanese? Interesting. Yeah, it says private repository. Is this a bug or is it because I have some setting somewhere? Ireland? It says German here. Let's switch to US. What the hell? Whatever. So it actually pushed an image. The size is 1994. The question is, where is this image? Is it this one? Ah, it's inside. Ah, there it is. It didn't grow, but it's still a different image. And it's 2006 was when it happened. And since then, we're waiting for Fargate. And I'm very curious how to actually see Fargate. Do I just go here? Yeah, apparently it is. So it's running tasks 2. Why does it run 2 tasks and not just 1? Oh, that's EKS. We don't want to go to EKS. We want to see this one here. Apparently it has 8.2 and it has 8.3, which might be, I think it's the versions of the images. Let's go to the image registry. Can't head back. We did. Okay. Do we see the name of the tag of the image? Docker container, no. Digest, image path, image tags. It doesn't really have a tag, apparently. Not, let's say not a readable. Or is this just, let's do echo -n, this, and we do, so it looks like base 64, if you look closely. So let's do base 64 -d. No, it's gibberish. So it's not base 64. Apparently. It looks a lot like base 64. I'm curious why this one kind of stalls here. Let's hope it works. It would be so good if it worked. Magical. Let's go back to ECS to see some more stuff and learn. So it is apparently running 2 tasks. I don't know why it's 2 and not just 1. Did we accidentally set the No, the task is still run, right? Even if we have container images or copies, replicas. How does it called? Deployment desired count. There we go. The minimum is 1. If the feature flag ECS remove default desired count is false, the default is 1. If true, the default is 1 for all new service and uses the existing service's desired count when updating an existing service. I have no idea what that's supposed to mean. So it's 1 in any case, right? I think it's 1. Circuit breaker. Interesting. ECS manage tags. Health check grace period. Load balancer name, listener port. Is anything happening here? It's creating the change set apparently. Why did you stall now? Please don't stall on me. We still need that one. This is pretty good. Definitely recommend it because it just works apparently. Except if you redeploy it, then it takes some time. So let's go to CloudFormation and see whether the update is still in progress. Yeah, it just takes forever. Updated at 0.6. It's quite some time. 9 minutes already. This one was... that's a different one. Oh, it worked. It worked! So this IP address should not have changed. Yeah, it looks very much the same. 180311. Yeah, it's the same. So that's nice. It's a static URI. And if we it was already called 33 times before we even started. But nevertheless, it works. Look at it go. Look at it go, ladies and gentlemen. It's amazing. We have the whole stack, 24 lines, to have a complete deployment. Well, basically, actually just this, right? Jesus Christ, that's amazing. That is amazing. And I mean, redeployment is this. You change the code and you just run this and all of a sudden the magic happens again. Jesus Christ. I wonder who's calling the endpoint. Something is calling the endpoint besides us. Maybe it's just a healthness probe. Heartbeat. But yeah, I think we did it. It's definitely running, and it's also running the same container continuously. And it should now be... yeah. Let's maybe look at that. Inside of ECS, we have one service running. We have CloudWatch monitoring running. Do we console log anything? I don't think we do, unfortunately. App service. We don't console log anything. That's a bit of a bummer because we have to completely redeploy again to see stuff inside of our monitoring. I hope that it works. So console.log current count. Well, let's just do this. Hit count. Okay. Let's do current count colon this dot hit count. Like so. And redeploy. CDK deploy. And look at it go, I guess. Do we want to do anything else? Because it takes some time. So maybe we can be slightly more generous in what we are doing. Do we want to do anything else? I don't think we do. We could put in a post maybe. Add post. And we want to have the subpath slash post. And we call it post test, which is a function and it returns nothing. Or let's say it returns a string. And what it does, it console logs post works. And maybe we get the add body right here. Yep. And we do body post works. And we put in the body right there. And then we return post works nicely. You posted. And then we JSON stringify this, JSON.stringify body, comma null, comma 2, so that it looks slightly nicer than it would without. You posted, colon. Okay, so save and deploy it again. So we put all of that there. We have git ignore. And I think we do want to commit at this point. Add episode 13.5. Add. And what did we do? Fargate on nest.js plus docker plus fargate plus AWS CDK. That's our complete stack. Magical. It's magical. Do we have a, like, I think it's Sparkle, right? Let's, so in the meantime, while we're waiting for it to work, I think we can close this one. I think we can also close this one and not go there, but here. We want to go to what exactly? GitHub emojis cheat sheet. I think it's :sparkle. Faces, people, activities, objects. Is it an object? Emotions, symbols. Sparkle. Yeah, sparkles. Okay. Sparkles. And maybe we have a wizard. Do we have a wizard here somewhere? Wizard. We don't. Magic. Mage. We do have a mage here. And I do want a mage man because he has a nice beard. It's magical. Let's commit. And wait for this to finish. And yeah, if that's done, I think we're pretty much through. Change something, and then what else do we want? We want now what we do is we want to check test post and test or receive post request, and we want also to see CloudWatch events or logs in CloudWatch. So CloudWatch is the logging service of our good friend. We do have a cluster here. There are no clusters apparently. Well, that's confusing. Because I'm pretty because it was under EKS. Sorry. We do have this cluster. This is our cluster. I see. Why does it run 2 tasks? That's confusing to me. It does have this. Interesting. It does have this service, which is good. Which uses our image probably somewhere. That's the container that's called Hollow Nest. Hello Nest, sorry. What is confusing me is that we have desired and we're running 2. Desire 1, run 2. Launch type is Fargate. Okay. So that's where we see that part. We don't have any ECS instances. It's either an external instance register using ECS anywhere or an EC2 instance. Yeah, that's exactly what we avoid by using Fargate. So that's why we don't have anything here. But for whatever reason, it has 2 of them. One at 07 and one at 20. Maybe because we're redeploying again. Could that be? Maybe it's vanishing as soon as this has finally finished. I think we didn't look again after our deployment actually worked. Let me switch positions here slightly and rehydrate rate. Rehydrate rate. Yeah, it's called rate. Yeah, so maybe just because of the deployment, there's actually 2 versions running. Does that change anything in our... Oh, it's a new one. So the count has been reset to 0 apparently at some point. We were like at 70. That means it's either it's a new instance that we're pinging or the containers. Did it show 72 just for a second? Or was it just my imagination? If I do this in pawn mode, does anything else happen? No, it's the same. Can we refresh for a second? It still has both. Platform version 1.4. Task. Why does it have 2 tasks? I'm confused. I have questions. Yeah, but other than that, we see that the counter has been reset. So definitely the container has been restarted, or it's a new container altogether. Come on, ECS, do us a favor. It's running, but it only has one active service. Raining service count 0. I am confused. But these are from our sessions, from our session definitely. Oh. So in the meantime, we can go to CloudWatch. We can go to CloudWatch and look at things, or maybe we can even do it from here. CS instances, delete cluster, services. Can refresh. Oh, did it finish? No, it didn't. But interestingly, we only have one running task now. So it is because of the update, probably. Do we have a new container now? No, it's the same, the second one. Interesting. Do we see anything inside of here? So we want to look at CloudWatch events, logs, Elastic Container Service, maybe. We do see that our app is somewhat busy with, it's running at 5%, then 5.35% of memory. CPU usage is also basically 0. If we run this very, very fast, deployment has finished, by the way. Nice. If we run this very, very fast and we reload here, there we see a small spike, but it's ridiculous, to be honest. Isn't this 1821? Oh, it's 5 minutes in the past, actually. Yeah, we don't see the current data point yet, apparently. Other than that, we should at somewhere we should see the logs, I would hope. Like the container internal logs, which are sent to standard out. But the question is, where is it? Okay, close that one. How do I see that? We can look at the task. We can look at the logs. There we go. Current count. Nice. There it goes. Look at it go. Look at it go. And we also see these guys. Can we look at them in run more like this? Can we not look at them inside of CloudWatch? That would be great. So if I rerun this, 100. Why is it 100 all of a sudden? We don't see them yet. Why is it 100 all of a sudden? I have questions. Come on. You should get at least one more. Maybe it didn't run the export yet. Probably it's doing its schedule and not pushing it from the container to... Yeah, the container definitely does not push the logs. The logs are pulled out of the container. So probably that hasn't happened yet. It would be nice if it did, though. Because then we see stuff. Public IP, private IP. Nice, 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 nice. Are you finished already? Not yet? Okay, that's too bad. Can we see them in cloud? Not CloudFormation. In CloudWatch. Watch. There we go. CloudWatch. And then not yet. If we go to ECS, so we do see this kind of fun stuff. The memory and all that, these shenanigans. What I'm trying to find is the logs. CloudTrail. Oh, that's a different one. CloudWatch logs. Maybe that's where we have to go. View log groups. Launch logs inside. Logs. Log groups. Oh, there's a bunch. They never expire, apparently. Insights. Insights is like if we want to search these events and logs, then we can use the insights. But if we just want to see our container insights, we're getting closer. Resources? No, apparently not. Not here. Services? Nothing. If we go to log groups again, do we find something like hello nest? There is. So if we go to that one, for example, view logs inside search log group, there is no log stream. We go to that one, there is a log stream. Yeah, there is. Okay, we found it. So going to CloudWatch, log groups, and then finding the correct application. Then we see the current count. Are we currently at 116? Yeah, somebody is calling this endpoint, which kind of confuses me. But anyway, this is the app start. I don't know why it's split like that into separate files. Is it a different? Sorry. Is it a different deployment? Probably it is, huh? They are older events. Okay. Yeah. So this is per deployment. We have one of these log streams. The question that I have then is, what are you? Task definition. They look pretty much the same. But for whatever reason, only one actually has any logs inside. Interestingly. I wonder why that is. But other than that, we did it. We can try one more thing, which is running a post request here. So I save this with the help of my neat little VS Code plugin. REST client. So saving as .http file, and we call it test, maybe just. And we do, so on the one hand, we can just get this guy, which works. You see, okay, endpoint called 128 times. And now I want to have a post, which has a, I think, a content type of application/JSON. Yeah. And we want to put in a JSON here. We want to say, hey, great job true. We need to have a comma. TypeScript t time this t time rocks, true. AWS other or comments. AWS CDK is amazing. Well, let's call it magical again. Yeah, magical. Magic. Okay, let's post. Cannot post slash, because we called it differently. I think we called it slash post. Just post works nicely. You posted nothing. Well, that's fine. I think all we did wrong is probably inside of the application. So I'm okay with that. Or if we do it like this, no, that doesn't work. You posted empty object. No, I didn't. Yeah, probably I did something wrong inside of this. Add a body. Route handler parameter decorator extracts the entire body object from the request object and populates the decorator parameter with the value of body. So it should work, if I'm not mistaken, but well, you can't have everything. It's fine, I guess. We did enough. We did more than enough. That was actually much more than I expected we would achieve, and it went much smoother than I expected that it would. So let's put this here. At the very end, you can always run CDK destroy, and everything will be eradicated. But you can, of course, just redeploy it. The URL will, of course, change in that case. But apart from that, most of the stuff will, in fact, be pretty much identical, which is amazing. So now it destroys everything. And it also does it in the correct order, if I'm not mistaken. First the subroutes, services, net, CS service. Can we still run it? No, we can't. Too bad. Well, that's fine. I can live with that. Okay. Man, we did a bunch. We did a bunch in this stream. Yeah, so this will just continue destroying. Thank you everybody for joining in. I definitely learned a lot. Hope you also learned something. And I'll hope you have a nice Sunday in whatever time zone you are. Here it's slowly getting darker and darker. Already getting closer to 21 o'clock. So thank you so much. Hope I'll see you next time in the usually the regular tea time at Wednesday, 18 to 20 o'clock in GMT +2, UTC +2, Central European summertime currently. All right. You can also find everything online at the GitHub, which is down here. And yeah, thank you so much for joining. Hope to see you next time. Bye bye.